issue to deal with in the observatory. So always check the website. And here we are. You come into the room. This is the dome that houses the telescope. There is the telescope itself, which I'll talk about in just a moment here. This is the building. This is the original building, the original dome, where the astronomers of Washburn Observatory have worked for going on 140 years now. There are other parts of the building and other things to notice that we'll talk briefly about, though, that we'll also talk about in our lecture about the history of the observatory. But this is the last remaining research instrument up here on Observatory Hill. At a time, once upon a time, there were quite a few. So the business end of the telescope. This is the eyepiece end at the bottom, right down here, and the telescope is of course movable. We have to be able to move it in various directions in order to point in the sky. So this is done entirely manually. This is a telescope that was built in 1878 and became operational in this dome, in this space, in the winter, in January of 1879. Here you can see the eyepiece. We would put an eyepiece in the telescope right here. Right now it just has a plug in there that helps keep the spiders out of the telescope when the telescope isn't being used. And the small telescope above that you can see right up here is the Finder telescope. So that's a 3.5-inch Clark refractor, just a small version of the bigger telescope of our 15.5-inch refractor. One controls the telescope at either at the end of the telescope or at the base of the pier, right here, that holds the telescope up. I'll point up at the mounting in just a moment. The north-south controls, what we call the declination, is that coordinate, are right here. You can lock it in place and then do a fine control with this knob right here. And then to go east and west, which in celestial coordinates is called right ascension, you can move the telescope manually, and very often you have to do this, although if you happen to be right here at the base of the telescope, while you can move it across large distances with this convenient wheel, which was a big innovation installed in about 1933, and a big improvement. The old mounting system had ropes at the front and back end of the telescope, and in order to move it a large distance across the room, at least it would require two operators to control the telescope, sort of like setting the sails on a sailing ship. Inside the pier is the clock drive of the telescope, which I will start up. This is a weight-driven clock drive, which moves the telescope on its east-west axis, on the polar axis, which is the one you see sloping there from lower right to upper left. That's the east-west axis of motion. That axis of rotation is parallel to the Earth's axis of rotation. So as the clock drive spins, once it's engaged with the telescope, right now it's disengaged. Once it's engaged, it will move the telescope at the same rate that the stars cross the sky, that rate being effectively one rotation in 24 hours, a sidereal day, a day as measured by the stars. And the clock drive runs the telescope at exactly that rate, so the telescope itself will make one rotation on that axis up there in 24 hours. So right now you can see that the telescope tube is on the west side of the pier, and in 12 hours it would flip itself 180 degrees and be over here on, I'm sorry, that's the east side of the pier. It would flip in 12 hours over here to the west side of the pier, and normally we don't want that to happen. So I'll be sure and turn the clock drive off before I leave. Of course, if we want to observe with the telescope, then we must open up the dome so that we can see out. And the dome mechanism on the Washburn Observatory is very much a homegrown affair. Not that that was unusual in those days, in the 19th century. The slit that opens has been motorized, so I will start it up so that you can see the dome slit opening. It comes in two sections. So you see the upper section moving now. It's being hoisted up on steel cables that actually run along the sides of it, just inside the slit corridor, the slit opening there. And it's pulling that shutter, the upper shutter, onto the far side of the dome on the outside. So if you were outside, you would see this large shutter segment sliding up, and it will end up being parked on the far side of the dome from where the opening is here. After the upper shutter is open, then we can open the lower shutter. I spared you a few minutes of the rather tedious opening of the upper shutter, but that's now done. I'm going to open the lower shutter. So that was pure 1882 technology there, just opening with the rope. But now we would be ready to point the telescope out the dome. So we might do that by tipping the telescope up from the end. And because the telescope is rather long, one quickly has to end up climbing the steps on the scaffolding there to maneuver the telescope like this. And of course to reach the eyepiece as well, to see out the telescope. And so we're now pointed, actually not directly out the dome. I would have to move it just a little bit to have it pointing straight out the dome slit. But that's basically the operation, except that we still need to open the lens cap that covers the objective lens, the 15.5-inch objective lens up at the front of the telescope. So once again, 19th century technology reliably at work for us here in the observatory. So at this point, now we could aim the telescope at something in the evening sky out the slit, and the telescope would, once we engage the clock drive, the telescope would track that object while we observe it through the eyepiece. That's the essence of observing here at this with this 19th century telescope. Of course, we might want to see something that is not in the southwest, where the dome is normally parked, pointing to the southwest. So if we want to observe something that is in some other direction, we have to rotate the telescope dome. So fortunately today, that is motorized. I'm closing up the dome now, and it's nearly, that job is nearly done. But before we're done here in the